All right, here we are. Chapter 19. Yay. We thought we were done. We're not. This was included. You guys looked at what I sent out as to what's going to be included on the Apes exam. As soon as I get the lectures out, then I'll worry about how to do testing and reviewing and stuff like that. So we might be able to get some live format. Join the remind that's there, please. So, what are we doing? Oh, fossil fuels. Oh, thank goodness, because it's all on energy that we missed. So we'll go through that. Objectives. Yep, read those. Have a good time. So here's an example. Sorry, have to move the box that the cats are in. I'll be standing on this. So in Alberta, Canada, and the Keystone Pipeline, oil sands, also known as tar sands. You're going to need to know the different types of fossil fuels, and this is one of the ways that we can get oil. So oil sands, also called tar sands, are layers of sand or clay saturated with a viscous, wow, it's early in the morning, it's like 7, okay? Tarry type of petroleum called bitumen. Yeah, you know my pronunciation on some of these. This is bad. Huge areas of tar sand are available around Alberta, Canada, and the impacts of extraction and processing the oil are huge. So tar sands are this weird, you kind of have to squish it, you have to go through a process, you have to dig holes. I mean, it totally looks like huge gaping holes of black when you fly over it, because Canada is mostly green, okay, or snowy, And when you extract it, it just leaves huge gaping holes. It's just, ugh. So, to extract it, what do you got to do? Clear the forest. Number 1, bad, right? Strip mine the land. Oh, number 2, bad. Okay, mix deposits with hot water and chemicals to separate them. Now, what do you think that mixture is? Bad, I know. Store the wastewater in toxic tailing lakes. So now they're storing them in lakes. They lined them in theory and all stuff like that, hoping that it doesn't contaminate the area around it. We already know. Bad plan, okay? Until oil prices began rising in 2003, extraction and processing of oil from these deposits was not profitable. Okay, one of the biggest buyers of tar sand oil is the United States because it's so close, and we just ship it right over the border. So, if you can remember way back to when we did our mining lab, okay, you had to decide if all of your chocolate chips had been embedded deep and you didn't see any of them. The amount of time it might have taken you in the process and all of your toothpicks you might have broken to get at it might not have been worth it in your cost analysis to go and get those chocolate chips. That's the same kind of thing that's happening with things like tar sands, and we're going to see some other examples. We have shale oil in our country. It's like where you're squishing the oil out of the rock, where there is no economic benefit unless the cost of oil is so high. So those are things that someone plugs the numbers on. Okay, to facilitate the transport, here are the oil sands. Ta-da-ta-da! Here's the proposed Keystone extension, the existing one, and look at what it goes through. Okay, so oil to the U.S. Trans-Canada construction, a large pipeline called the Keystone. We have to take it way down to here because this is where our oil refineries are. It's like, really? Come on, we can't think of something better? We'd rather make this than, allow Canada to process it and then give it to us, because then we'd lose that money, Texas and all. Okay, an extension of the pipeline has been proposed to be built through the Dakotas to shorten the distance, increase capacity, and reach productive oil fields in North Dakota and Montana. People were against it. Okay, a couple of years ago, we were even teaching this class when they were bringing it through. All the Native Americans were out there, all the people that were going through, everyone protested, okay? Oil use should be reduced. We should instead be transitioning to renewable energy. No kidding. That's solar, available every day. Oil spills could contaminate the sandhill areas of Nebraska and the Ogallala Aquifer. Look, did you see the picture? Look, that's so, and here, and we're already sucking up the water, now we're contaminating the water. not a bunch of thinkers, those people who are concerned with their money. 2015, President Obama decided against approving the pipeline. You know the pipeline went through. Look, there's no one here for me to talk to, but you know the pipeline went through with our current government, and like pretty much weeks after he said, okay, it's never gonna, it spilled, it leaked. Because look at it, I mean, we saw how long was that pipeline? Pipe things fit together. It's not like they had a continuous 3,000 mile pipe. No, it has to join together and crap happens and it spilled, and that's like, that's just a cluster boo-boo, okay? So here are energy sources we use. We've devised many ways to harness the renewable and non-renewable forms of energy available on our planet. When we start thinking about renewable, everyone's like, no, I like combustion. Okay, we know we have one person who likes combustion in our classes, all right? But the fact is that we've moved on, we've learned technology. I mean, think back, not you, maybe not your grandparents, but like originally telephones were like women sitting back there going, oh, hi, Judy, you want to talk to Sally? And they plugged it in. You didn't see the big riots when telephones got better, did you? No. People found new occupations, find new lines of work. Here are different things we can do. You look at that in your own time. You can press pause. Okay. You know, multitasking here. Not only am I watching for people who have to go to the restroom, okay, not. I'm just making sure the dog doesn't fall off the edge. Most of the Earth's energy comes from the sun. It's coming anyway, whether we harness it or not. Why would we not harness it? Why would we not? Okay, which drives wind. The reason why we have winds is because of uneven heating on the planet, and it causes the wind to move. Okay, water cycle, you already know about that, and photosynthesis. Thank you, plants and, you know, algae and those bacteria and stuff. So, when plants and other organisms die, they're buried in sediments under particular conditions. Their stored chemical energy may eventually be incorporated into fossil fuels. That's a literal name. It's a fuel coming from dead things, fossils, such as oil, coal, and natural gas. Other forms of energy in the earth include geothermal. Iceland's doing pretty good on that, okay? We got that whole Yosemite thing. All right, I don't know how we do that, but it's underneath the super volcano, okay? From the core and from the bonds between protons, neutrons, and atoms. Okay, and that's nuclear, just in case you weren't in chemistry or you just weren't paying attention at some point. So, energy sources like sunlight, geothermal, tidal energy, tides happen all the time too, are perpetually renewable. How do we harness it? What kind of technology is out there? There is technology out there. So coal, oil, and natural gas are considered non-renewable because it takes thousands of years for the biosphere to generate the organic matter consumed by our society in a single day of fossil fuel combustion. So here we can see, once again, there's our graph. Yay, we rely mostly on fossil fuels since the Industrial Revolution. Once again, we can follow climate change starting with the Industrial Revolution. I don't know, there's the tie-in to the fossil fuels. Just saying. The high energy content makes these more efficient to burn, ship, and store, all of these fossil fuels. We use fossil fuel for transportation, manufacturing, heating, cooking, and to generate electricity. Here we got coal, oil, natural gas. You should know that we're the big coal people, okay? As you know from the slogan of the president that we have right now, he's bringing coal back because that would employ an awful lot of people. He didn't tell me he wasn't going to sponsor and be okay with their healthcare system that helped them when they, you know, like sucked those particulates in and got lung cancer and crap like that. But you know that's another story. So the distribution of fossil fuel reserves varies from region to region. Here we have, look at us, energy consumption. Good job. Okay, and over here, you all know where that is. I'm not saying it because, you know, I'm going to get it wrong. So, developing countries tend to use energy for subsistence activities. So, in other words, just to live. We use it for extraneous stuff, like, I don't know, having homeschooling on your computer. Okay, probably wouldn't die without that, but, you know, these are not decisions I make. Holy cow, you guys... Look at that. You know things like, in the United States, coal, oil, and natural gas supply 82% of the total energy. consumed, used in each sector. Look at all that. Oh my goodness. All right. And we know burning all that heat, we haven't figured out how to harness that yet. So when we burn for fossil fuels, or we burn, say for example, that car thing, touch it, it's hot, we haven't figured out how to take that heat and utilize it. So harvesting energy requires the use of heavy machinery, construction of roads, pipeline, waste ponds, storage tanks, all requiring investment of energy. So it's not just the burning of the, let's say, go with the oil. It's the production of the oil. It's the pulling it up from the underneath the ground. It's the transporting it someplace. It's refining it, because you can't just use the oil that comes out of the ground. You got to do stuff with it. Then you have to bring it back to another place. I mean, that's a lot of movement. So it kind of self-perpetuates. Net energy expresses the difference between energy returned and energy invested. Just in case you didn't get that. So energy sources are assessed using EROI, energy returned on investment. And once again, here's a graph. Who doesn't love a graph? You do by now, I'm saying. So here are our years, okay? Here we could still discover them. Now they're saying, there's not much discovery left to be happening, okay? So ratios rise when extraction becomes easier or more efficient, and lower when sources become depleted. The ratios for conventional oil and natural gas in the U.S. declined from 24-1 in the 50s to 11-1 in recent years. They're not making the profit that they used to. Enormous amounts of energy, money, and technology are now being used to extend our reach of fossil fuels. Good job. Instead of turning to something that, I don't know, maybe easier, we're going to keep with the same thing. You keep banging your head against the same wall, okay, and you're expecting different results. You're not the sharpest crayon in the box. Oil and gas wells are being drilled deeper and into places that were once unreachable. Arctic seabeds, because they're not frozen anymore, so you can get to them. Farther offshore in the ocean, go and look at a map that shows where all the oil drilling platforms are in the Gulf of Mexico. New resources such as oil sands are also being tapped. Get ready for it. Okay, not yet. Fossil fuels were formed hundreds of millions of years ago. Here's how they form. Fall down, squish, okay? So this goes through the process. You need to know that they are anaerobic conditions. So look at this again, or pause and enjoy it for now, because you should know the steps that went from hi, I'm a tree, to hi, I'm coal and oil. Okay? Coal, just a heads up, coal is never clean. Just giving that stuff to you on the front end. It's a hard, blackish substance formed from woody organic matter compressed into a dead solid carbon structure. The more coal is compressed, the denser the carbon content and the greater its energy content per unit volume. And we're going to go through and talk about the different levels of coal. Extracted primarily through strip mining, subsurface mining, and mountaintop removal. Sorry, gotta get through. Okay. He jumped himself. It's just awkward when he does that. 3 legs, face plant. Sorry. So crude oil is unrefined oil extracted from the ground. Natural gas, as the name implies, consists primarily of methane and other volatile hydrocarbons. You need them to be, Petroleum is usually referred to oil, but may also refer to oil and natural gas collectively. It just depends. Oil and natural gas are derived from marine plankton that died, sank to the sea bottom, became buried, and transformed by time, heat, and pressure. So now we're sucking up a bunch of marine plankton. This is why it's so hard. We must be drilled through the ocean before we can get it. So here's showing you all the process involved. Okay, oil sands, strip mines. They got to squish it, pour it into a machine, stored, hot water, bitumen rises atop to a slurry. It's skimmed off, mixed with solvents, processed into synthetic crude oil. Okay. Steam and solvents, we know. I love it when we pump stuff into the crust to get stuff off. That's always a good plan. Oil sands are a mixture of moist sand and clay containing 1 to 20%, no one's going to ask you, bitumen, a thick and heavy form of petroleum. Oil sands form when crude oil deposits are partially degraded by bacteria. So it's almost like they're taking sand and they know that it's kind of, this is the rough, and they're squishing and combining it with chemicals in order to get the oil out. And they can only do this when oil prices are really high, otherwise it's not worth the effort. So oil shale is a sedimentary rock filled with organic matter that can be processed into shale oil. Okay, so the shale rock can become shale oil. See that? Okay. It occurs in areas where deposits were not buried deeply enough to be subjected to enough heat and pressure to form oil. So then we have methane hydrate. You chemistry people already know what that is a solid consisting of molecules of methane embedded in a crystal lattice of water molecules. It's found in the sediment of the Arctic and ocean floor. So that can't be good when that comes up, because we know methane is the most efficient greenhouse gas. So the proportions of fuel that are physically accessible are called technologically recoverable portions. The economically recoverable portions, I don't know if I said that right, of the fuel depend on cost of extraction and market price. This is what I've been saying all along. It depends on if it's worth the effort. Someone's cranking the numbers as to where they start making a profit, as to whether or not they're going to go and extract shale, whether they're going to do tar sands. Is oil, at a price point where we should go and start looking for new oil wells? Okay, all of that is taken into consideration. So proven recoverable reserves are both technologically and economically recoverable. Get that. Proven recoverable reserves. We can get it, and it's worth getting. Okay, so you need to understand how this works and what we get out of our crude oil. Okay, it's a mixture of hundreds of hydrocarbons and must undergo refining. So it comes out and we get all of these things. Okay, a process that separates the molecules by size. Look, it's a distill. It's a distill. Wow, it is a distillation column. And you can see here's residue, which we have to get rid of, which we always do. We got to boil it. Okay, so now we have to add all this energy in order to get this out. Okay. The separated products of refining are specialized fuels for heating, cooking, transportation, are also used to make lubricating oils, asphalt, how we make our roads, and other petrochemical products. So, this is what we have: heavy fuel, liquefied petroleum gas, jet fuel, diesel fuel, and heating fuel, gasoline. Are they going to ask you those percentages? No. Okay. Fossil fuel has many uses. Well, no kidding. Okay. The amount of fossil fuel that nations extract and consume depends on its size and the level of industrialization. So in other words, do we keep all of it? Do we ship it out? I mean, we ship out coal because we have a lot of electric plants that are used for something else. And why would we burn coal when we could burn something else? So it's like we ship out coal, but we bring in this and that, and it's like, I don't know. It doesn't seem like there was a lot of thought process put into this. So coal, for example, is primarily used for electric generation. Because what else? You can't stick it in your car. So here we have how it works. Look, every electric generation plant works the same. Somehow or another, water is heated. Here we've got it through coal. It turns a turbine, okay, which then produces electricity in a generator and sends it out. Always. There's something that's heating water that causes the turbine to go, unless you're talking about, hydroelectric, then the turbine's just going all by itself, okay? So long as you know that, you can answer that question with things. And we'll get that also in nuclear power, how a nuclear power plant works. So here are the things. Look at this. We're still getting rid of toxic ash. Where are we taking it? Okay. Hazardous waste landfills. And then hazardous for how long? How do we store it? Do we have to protect it? Is someone going to blow it up? I don't know. Look at all the things we do. Let's all feel badly about all of this. I'm not feeling badly about brushing my teeth, but you know you don't have to get a plastic toothbrush. I'm just saying nowadays, other options are out there for you. So since fossil fuels are non-renewable, the total amount available on Earth declines as we use them. Analysts calculate the reserve to production ratio by dividing, really they're telling you how to do the math, even though they're telling you, by dividing the total remaining reserves by the annual rate of production. The numbers don't matter, okay? But what they're saying is the current estimate of oil reserve is about this much, and the rate of production is this much. Okay, so that gives us about 53 years when this was made in, what, 2018. Are we changing that around because more places are using solar? Saudi Arabia, they're generating most of their electricity by solar because they're not stupid. And they have a lot of sun in that desert thing. So natural gas reserves, they're saying about 54, coal 110. I don't know if we'd make it if we kept burning coal at the rate, but... So the actual amount of years we have left could change if our demand, production, or known reserve changes. For example, hydraulic fracturing is allowing us to access tight oil confined in or near shale. So, okay, we have more energy, but those earthquake things really suck. It's just, okay? Eventually, extraction of any non-renewable resource will reach a peak that declines. That's how we know we've reached a peak, when we start going down the other end. So if demand holds steady or increase when this happens, the shortages are likely. This scenario is called peak oil with petroleum because it's likely to occur in the near future. So it's like, why don't we get on board before we run out of crap? I just change it over. You know, change it over slowly. I mean, first we're doing electricity and our cars. Eventually, maybe airplanes, you know. So here they're showing you, Shell oil geologist, this dude, no one's going to care, predicted the U.S. would hit its peak in 1970. Oh, look, it came true. Although unconventional sources have increased production back towards those levels. So probably then we started getting into, you know, the tar sands and the shale and stuff like that, that he didn't understand its availability back when he made that prediction. Ooh, pretty graph. Okay, the world is going to reach its peak sometime soon. Look, they have us here. Okay, I don't know. Maybe, you know, we're close. Just work with it, because you're not going to need to know the numbers. Once again, reading the graph. So there we go. You can read the questions on your own time. Coal. Okay, which fossil fuel is a mixture of hydrocarbons? Ta-da! Oil. Okay. Unconventional, Alberta, Canada, oil sands. So how do we extend fossil fuels? Look at all these good plans. Mountaintop mining for coal. So let's just take off the tops of some mountains and look for coal. Secondary extraction from existing wells. Okay, going back down, adding some pressure, adding some of those chemicals, almost like fracking on wells that you already have. Hydraulic fracturing for oil and gas, offshore drilling, because that worked well for us, you know. The Gulf of Mexico is still screwed. Exploiting new unconventional fossil fuel sources. I don't know, if they just put exploiting at the front, does that seem wrong? I don't know. These all increase fuel production but reduce the EROI ratios for our fuel, intensify pollution, and worsen climate change. Guys, I'm going to be sending you a link that came from NASA that shows what's been happening to gases over China since China's been shut down for the past couple of weeks. It's amazing. Go look at those pictures of Venice, how they can see at the bottom of the canals because no motorboats. The planet will fix itself if we as humans stop messing it up. Look how pretty. Why do we want to do this to our planet? Mountaintop removal mining removes entire mountaintops to access coal seams running through them. Huge amounts of rock and soil erosion. You think because we have no trees holding onto the soil anymore? Yeah, kinda. So a typical oil or gas well, as much as 2/3 of deposits may remain in the ground after primary extraction. Because first we take the easy stuff, then we go back and get the hard stuff when the money is right. So in other words, when the cost is worth the effort. In secondary extraction, solvents, water, or steam is injected into the wells to force the remaining oil or gas out by pressure. Much more expensive. So once again, they may know they've sucked most of it out or drilled most of it, whatever it may be, and they keep that well there. And then when the cost of oil goes up so that it's worth the effort, then they go back and do the secondary. So directional drilling technology allows drillers to bore down vertically and then curve to drill horizontally. So there are some places, I don't know what it is in Florida, but there are some places where you do not own the ground below you. So if an oil company goes, a half a mile out because that was land that they were allowed to drill, and then they drill down, then they can drill sideways underneath your house. Oklahoma had some fun with this too. This allows drillers to reach a large radius around each drill pad without constructing additional drill pads. Nice. Who doesn't want that in their backyard? Come on. Hydraulic fracturing, also not called fracking. Go back and review the fracking song. I'm just saying. Maybe I'll put a link so you can enjoy that in your spare time while you're sitting there. Okay. Chemically treats water under high pressure into layers of rock to crack them. It's become a major debate in states above the Marcellus shale deposit as it creates many jobs, but drew down water resources and in some cases polluted the water. So now I have less water and the water I have is polluted. But thank goodness I have a job. Can't we make solar panels, man? I mean, throw up a factory there. Let's do something else. Knit some masks. Okay. Roughly 35% of the oil and 10% of the natural gas extracted in the U.S. comes from offshore sites such as the Gulf of Mexico and coastal California. How'd that work for us? Deepwater drilling technology has outpaced our ability to deal with accidents, as shown in this Deepwater Horizon oil spill. I just have one of my magazines that I'm sitting here during the day when I'm not trying to figure out how to upload crap and figure out how to do stuff online. It shows that this spill is still affecting the Gulf of Mexico. It's showing areas where the oil is affecting it, and areas where the disbursements that we used are actually toxic and they have die-offs from the animals from what we used. I mean, it was just a cluster boo-boo that we had no idea how to contain. This forced a temporary hold on new drilling in 2011 until new rules and regulations could be designed. And there's the people upset over that platform. So, global climate change has opened up many areas of the Arctic. You would imagine this is going to cause positive feedback because, once again, climate change allowed the ice to melt. And then you have fossil fuel being burned because you need to burn it in order to drill in that area and then to take it out, which is then going to cause more heat, more albedo effect. We did that last chapter, remember? Okay? And it's just going down, okay? Only Royal Dutch Shell has attempted to drill in the Arctic, but a series of accidents and protests led them to withdraw. Yay. So now you know. Don't go buy a Shell. Bad. I don't know. Go to electric. Put some solar on your roof so your solar can charge your electric car. Stick your tongue out at all of them. No. Okay. There's an estimated 3 trillion barrels of oil shale to be extracted, much of it in the United States. Oh, good news there. The ROI for this is low. There are some ratios. No one's going to ask you. Methane hydrate is also abundant, but so far only Japan has attempted to extract it due to its concerns about accidental release of methane. Whoopsie, we don't want a whole big thing to go off. It's hard to contain that gas stuff. Oh, look. This is Alberta. I told you. Because normally Canada, when there's not snow, is green, except here. And look. Wait. Trucks. I'm just saying. That's a truck. That's probably the trailer, those are trucks. That's a large area. So our impacts of coal, what do they include? Health risks to subsurface miners due to mine collapse. That just happened in Chile, a couple of years ago. They did a whole movie and stuff about it. Okay? Inhalation of coal dust, which your lungs do not like at any point. Extensive soil erosion. Finishing this one. Acid mine drainage with sulfide minerals An exposed rock react with oxygen. I'm going to have to cut it off. I will be back. Don't move.